When in 1977, the world was singing along to Queen and dreaming of distant space thanks to Star Wars. NASA launched two probes that became symbols of human bravery. Two small devices, created by humans, ventured to places where only imagination dares to look. Today, they are at a distance of 15 billion miles from us. But what discoveries have they made beyond the influence of our star? Perhaps today we are approaching revelations that could overturn our understanding of the universe. What lies beyond the reach of sunlight? And what secrets do these ancient messengers from Earth hold? Let's embark on a journey together to find out. The long-lived probes. Imagine a time machine the size of a car that has been operating for 47 years. These are the Voyagers. Two probes whose brains are weaker than a modern phone, and their power is comparable to a refrigerator light bulb, and yet they continue to fly, traversing space that is hard to even imagine. Their energy center. Plutonium generators that keep the probes running even after decades of flight. But what makes them so special? Remember, their computers can perform only 81,000 operations per second, while your smartphone surpasses them by thousands of times. And their data transmission is so slow that downloading a 5 GB movie would take them over 8 years. Nevertheless, these probes have done what no other device has managed. They have left our solar system. How did they manage that? The answer lies in their reliability and well-thought-out design. For example, in 2017, Voyager 1 successfully used backup thrusters that hadn't been activated since 1980. How is that possible? Doesn't it seem to you that this is more than just technology? Perhaps it's a symbol that humans are capable of creating eternal things when they put their heart into it. The original mistake. The Voyagers were supposed to complete their mission in 5 years. How did engineers in the 70s manage to create devices that exceeded all expectations? The answer lies in gravitational slingshot, a unique technology that uses the gravity of planets for acceleration. Just think about it. Jupiter and Saturn became springboards for these probes, increasing their speed to 38,000 miles per hour. It was a real breakthrough, as no one had tried anything like it before. But what if this plan hadn't worked? What if one mistake had led to the failure of the entire mission? Interestingly, the mission was originally planned only to study Jupiter and Saturn. However, scientists decided to take a risk and directed Voyager 2 further, towards Uranus and Neptune. This decision opened up new horizons for us that we hadn't even suspected. Don't you think that sometimes the biggest discoveries happen by chance? After all, it was precisely such decisions that led us to what we know today about the boundaries of our solar system. Ios, volcanoes. The first surprise. When Voyager 1 approached Jupiter's moon Io, it discovered something that revolutionized scientists' understanding of planetary moons. On the surface of Io, active volcanoes were discovered, erupting lava up to 186 miles high. This is higher than the tallest mountain on Earth, Everest. The small moon, slightly larger than our moon, turned out to be the most geologically active body in the solar system. What drives this tiny world to bubble like a cauldron of boiling magma? The answer lies in the powerful tidal forces exerted by Jupiter and neighboring moons on Io. These forces stretch and compress its interior, causing extreme temperatures. Why Io, specifically? Perhaps it is related to its unique composition or orbital resonance with other moons. This discovery was the first link in a chain of surprises, revealing the inexhaustible mystery of the solar system. Every new object that the Voyagers explored seemed increasingly mysterious. What else lies beyond our understanding? The rings of Saturn. When the probes approached Saturn, their cameras captured something that astonished even the most experienced astronomers. The rings of Saturn, perceived as a frozen ornament, turned out to be full of movement and complex processes. They resembled spiral waves, as if someone had thrown a stone into a silent cosmic pond. These waves stretch for thousands of miles, and each one tells its own story. Scientists suggested that these structures arose as a result of ancient collisions, the echoes of which continue to resonate millions of years later. But what if these are not just traces of the past? What if they are the key to understanding how systems form and evolve? The rings around planets? Saturn seemed to have revealed its secrets, but in reality, it only deepened the mysteries. Its rings are not just an adornment, but a complex system that holds information about the planet's very origin. Are such structures found only on Saturn? Or is it a universal mechanism that we do not yet fully understand? Uranus, the rogue planet. Uranus has become a real challenge for scientists. This ice giant rotates on its side, as if knocked over by an invisible blow. Its magnetic field behaves chaotically, as if playing hide-and-seek with observers. The temperature on its surface drops to -371 degrees Fahrenheit, making it one of the coldest places in the solar system. Voyager 2 discovered that Uranus experienced a catastrophic collision in the distant past. But who delivered this blow? Was it another planet, or a massive object from the Kuiper Belt? Perhaps this event changed not only Uranus but the entire structure of our solar system. This rogue planet with its strange behavior and mysterious history has become a symbol of the diversity of our system. It reminds us that even in a familiar cosmic environment, there is always room for surprises. What other secrets does Uranus hold? And what can it tell us about the early history of the universe? Neptune. Bam. 1989, Voyager 2 made its final stop in its grand mission. It reached Neptune. This distant world, painted in bright blue, turned out to be full of mysteries. Its moon Triton, which looked like an icy desert, surprised scientists with its nitrogen geysers. These eruptions rose up to 5 miles high, as if the planet was trying to breathe through cracks in its crust. But the most interesting discovery awaited researchers in the data about Triton's origin. It turned out that this moon is a runaway from the Kuiper Belt, a cold and distant region beyond Neptune's orbit. How is that possible? Perhaps, billions of years ago, Neptune's gravity captured it, turning it into an eternal satellite. But what if it's not just a coincidence? What if such abductions, a common occurrence in our solar system? This discovery became the final note of the Voyager 2 mission. After that, the probe left the planetary system, heading into the uncharted expanses of space. But what awaits it there, beyond the known world? The heliosphere. The sun is not just a source of life. It creates an invisible shield extending billions of kilometers, the heliosphere. This bubble extends 7 billion miles from the sun and serves as a shield, protecting us from cosmic radiation. Without this protection, Earth would be constantly exposed to high-energy particles that could destroy all life. The heliosphere is formed by the solar wind, a stream of charged particles emanating from the sun. However, its boundary, called the heliopause, is not a wall. It's a complex and dynamic structure. Scientists long believed that the solar wind gradually weakens as it moves away from the sun. But data from the Voyagers show that the situation is different. The wind abruptly stops when it encounters the interstellar medium. This place resembles a front where two forces meet, the solar and the interstellar. What lies beyond this boundary? And how reliable is our protection? The answers to these questions could change our understanding of how the universe is structured. The heliopause. When the Voyagers crossed the heliopause, they discovered something completely unexpected. Instead of the clear boundary that scientists expected, they encountered a frothing foam millions of miles high. This place resembles a boiling cauldron where the solar wind collides with the interstellar medium. Space here literally boils, creating chaos from particles and energy. This turbulent foam has become a real mystery for researchers. Why is the boundary so unstable? Why does its shape change over time? Scientists suggest that this is related to the pressure of the interstellar medium. Perhaps it is a consequence of ancient supernova explosions that have left their mark on our part of the galaxy. The density is invisible. When the Voyagers reached the boundary of the heliosphere, they discovered something astonishing. The density of space here increases sharply. Inside the solar system, the density of charged particles is about 3 to 10 particles per cubic inch. But beyond the heliopause, it increases 40 times. This discovery has become a real mystery for scientists. Why does the density change so drastically? Imagine a filter through which particles pass. This is exactly how one can describe the process at the boundary of our system. Here, the solar wind collides with the interstellar medium, creating peculiar particle jams. This process resembles chaotic movement, where particles collide and get trapped at the boundary of two worlds. But what causes this effect? Perhaps it is related to the interstellar medium being denser than expected, or the solar wind losing its strength faster than anticipated. This discovery has made scientists reconsider their models. Space, which we are used to thinking of as almost a complete vacuum, turned out to be much more complex. What else is hidden in these distant regions? Interstellar hurricane. The Voyagers discovered that beyond the heliosphere, they encountered a real interstellar hurricane. Particles born from supernova explosions were traveling at the speed of light. These high-energy elementary components, called cosmic rays, permeate space like invisible arrows. But surprisingly, their source is not in our galaxy. Scientists suggest that these particles are accelerated by powerful supernova explosions that occurred billions of years ago. These explosions create shock waves that spread throughout the galaxy. Try to mentally picture how. A stone thrown into water creates ripples on the surface. Only in this case, these ripples are waves of energy that accelerate particles to incredible speeds. The magnetic web. Beyond the solar system, the Voyagers encountered another mystery. The magnetic field here turned out to be 3 times stronger than expected. This discovery was a real shock for scientists. Space turned out to be permeated with an invisible network of magnetic lines, weaving a complex structure. Imagine an invisible web whose threads envelop the galaxy, connecting stars and planets. These magnetic threads create a structure that influences the movement of particles and even the formation of stars. But who wove this web? Perhaps it is the result of interactions between stars, planets, and other cosmic objects. This discovery made scientists think. What if magnetic fields play a much larger role in the structure of the universe than we thought? Sounds of the void. The Voyagers heard what seemed impossible. Sound in space. At a distance of 9 billion miles from Earth, the devices recorded a low-frequency hum that lasted almost 3 years. This sound was stable, with a frequency of about 3 kilohertz, and scientists suggest that its source is plasma waves traveling in the depths of space. But how is that possible? After all, there is no air in space, which means sound cannot propagate. However, this sound is not a typical acoustic phenomenon, but electromagnetic oscillations converted into an audible range. It's like a message from the depths of space, a key we are only beginning to decipher. Interestingly, this hum remained almost unchanged even when the spacecraft traveled another 620 million miles. Such stability makes one wonder if there is an energy source sustaining this phenomenon, or if it's simply an echo of long silent events. 50,000 degrees in space. Beyond the heliopause, the high speed of particle movement creates the equivalent of plasma temperatures reaching 54,000 degrees Fahrenheit. But how is this possible when the Voyagers are surrounded by icy cold? The answer lies in the rarity of the environment. Try to mentally picture a heated pond of metal that seems invisible in the dark because its particles are too sparse to transfer heat. It's the same here. The plasma is so rarefied that its energy is not felt as heat. This discovery became a real paradox for scientists. Why is the temperature so high, yet the density remains extremely low? Perhaps it's because interstellar space is filled with high-energy particles that interact with the solar wind. But where does all this energy go? Scientists suggest that it dissipates in the form of electromagnetic waves, but there is no exact answer yet. This phenomenon reminds us that even in the most distant corners of the universe, the laws of physics can manifest in completely unexpected ways. What else is hidden behind these mysterious processes? The twin adversaries. Voyager 1 and Voyager 2 are 2 probes launched as part of the same mission, yet they see completely different space. One of them ended up in a stream of particles, while the other was in a bubble. Why do their data differ so much? Perhaps it is related to their trajectories or the fact that the heliopause is not a static structure. Imagine a bubbling stream whose flow unpredictably changes under the pressure of cosmic winds, creating eddies and whirlpools. The heliopause is like this river. Its shape changes under the influence of external forces, such as the interstellar wind and environmental pressure. This might explain why Voyager 1 observes a more chaotic picture, while Voyager 2 sees a more stable one. But what if these differences indicate something more? Perhaps this is the key to understanding how our galaxy is structured, or it's just a coincidence caused by the unique conditions of their flight. For now, scientists can only speculate. The secret of the shape. The heliosphere is not a perfect sphere, as scientists previously assumed. It is more like a flattened donut, where one side is stretched into a long tail and the other remains more rounded. This discovery was a real surprise, as the shape of the heliosphere directly affects its ability to protect our solar system from cosmic radiation. Try to mentally picture a balloon being squeezed from one side. As a result, it deforms, creating an uneven structure. Similarly, the pressure of the interstellar medium shapes the heliosphere, making it asymmetrical. But what if this protective shell turns out to be not strong enough? Perhaps one day we will face the consequences of its destruction. This shape also changes our understanding of how other star systems are structured. If the heliosphere of our system is so complex, what can be said about other stars? Could their bubbles have even more bizarre shapes? These questions remain unanswered for now, but they open new horizons for research. A messaging to the void. On board each Voyager is a golden record. Thus, a message from humanity to space. This record contains sounds of Earth, music, human voices, sounds of nature, even chimpanzee calls. In 40,000 years, Voyager 1 will pass within 1.5 light-years of the star Gliese 440. 5 in the constellation Camelopardalis. Will anyone hear this message? Scientists acknowledge that the likelihood of the Voyagers being discovered is extremely low, even if an alien civilization finds our spacecraft. They will face a series of puzzles. Will they be able to decipher the symbols and sounds on the record? Perhaps this message will remain an artifact that is never understood, but even if no one hears us, the very existence of this message holds great significance. It reminds us that we are part of something greater, that our hopes and aspirations can endure. Time and space. The final signal. The signal from the Voyagers reaches Earth in 20 hours. Each transmission is like a cry into the void, a reminder that they are still alive. But time is running out. The probe's batteries, powered by plutonium, are losing power at about 4 watts per year. This means that by 2030, their instruments will start shutting down one by one. These devices, having survived nearly half a century of space travel, are slowly fading away, like old lighthouses whose light no longer shines through the darkness. Scientists are already preparing for the end of the mission. First, the scientific instruments will be turned off, then the communication systems. When communication ceases, the Voyagers will become silent wanderers, carrying our trace through eternity. But is this the end? Or is it the beginning of a new chapter? Even after losing communication, they will continue their journey, carrying with them the message of humanity. How long will they drift in this endless darkness? What's next? Where are the Voyagers headed? Into the abyss? Just think about it. In 300,000 years, Voyager 2 will pass within 4 light-years of Sirius, the brightest star in our night sky. And Voyager 1 is heading towards the small star Gliese 445 in the constellation Camelopardalis. But what if humanity disappears long before anyone finds these spacecraft? This question makes you think. Is there any point in sending messages into space if the likelihood of them being discovered is minuscule? Perhaps it's not just an attempt to make contact with other civilizations, but a way to remind ourselves of who we are and what place we hold in the universe. The Voyagers are a symbol of hope. They remind us that even in the most distant corners of space, we can leave a mark. But are we ready to follow them ourselves? Are we ready to become part of that boundless universe we have so eagerly sought to understand? The pale blue dot. The last photograph taken by Voyager 1 in 1990 became one of the most significant images in human history. In this photo, Earth is visible as a tiny dot, lost in a beam of sunlight. Measuring just 1/10 of a pixel, it appears as a vulnerable point in the vast emptiness. All of human history, like a grain of sand, is contained within that tiny dot in this image. Carl Sagan, who was inspired by this image, wrote the book Pale Blue Dot. He said it serves as a reminder of our vulnerability and at the same time our uniqueness. This image became a symbol of the realization that we are part of something greater. We live in a fragile bubble that protects us from the vast cosmos. But what will happen if this bubble bursts? Are we ready to face this reality head-on? Today, the Voyagers are in a foreign galactic environment, but their cameras are pointed towards Earth. This is symbolic. Even after leaving our system, they continue to look back, as if waiting for us to decide to follow them. What do they see from their point of view? Maybe they are observing how we change, how we develop technology, how we dream of the stars. Perhaps they are waiting for us to realize that the boundaries of our planet are just the beginning of the journey. The Voyagers are not just machines. They are the embodiment of human curiosity, courage, and the thirst for discovery, flying towards the unknown. And as they fly forward, they remind us that space is not just a void, but an opportunity. An opportunity to become part of something greater than ourselves.